At a given point of time, you had only this, and therefore you could do. So this is a very, very interesting statement that I found, wherein he had a much larger understanding of how the nature of science is. See, many of you may be remembering that there was a huge event which happened in 2011, you know. So there was a huge burst, and then the entire island of Japan went by 7 feet. Okay, you can see in the web also. So this was a magnitude of 9.1 earthquake that happened in Pacific. The reason I am saying this is, see, this event they have analyzed later, and then based on the precision that you have today in measuring things, they have come to the conclusion that this phenomenon that happened on the earth increased the acceleration of the earth. So there is a continuous phenomenon which is happening, and the earth is decelerating. When I say earth is decelerating, it means today if it is 365, after a million years it will be 364 per year. Yes.
Is that like a cycle, like the Shigra Manda?
No, they are two different things. That is just with respect to the computation of the orbit. So here, this Shigra Manda, as such, the words mean fast and slow, but they have a specific meaning in that particular context. This is a phenomenon which nobody knows when it may happen. So the point I wanted to make is, we have some data for a few hundred years at most, but we had the audacity to say that we will be able to predict for 5,000 years, 10,000 years, and so on. In fact, there were claims which were made by physicists that if I had a tool to compute, then I will tell you what the universe will be after 10,000 years. I mean, that is the way they progressed. But then today everything fell flat. I mean, the advent of nonlinear dynamics in 1960s. So they realized that things are very complex. So this is a phenomenon which accelerated the rotation of the earth. So we will not be able to say with great confidence. I wanted to quote this, the earlier passage, and give this only to mention that their larger understanding of how the science is, okay, is something which we understand in a different way today. Okay. So there, this last part of the talk, maybe I can even skip this. This has to do with some important discovery. See, the point is, Earth has two types of motion. One is this rotational motion, the other is the revolutional motion. You ask any student, even in IIT, suppose I ask some students, so how do you know that Earth is rotating or it is revolving around the sun? I don't think any of us can give an answer. We just study things and then we take for granted, right? So this question is not easy also. That is why people have been struggling for hundreds of years. For your information, though Copernicus said that it is moving around the sun, it was not based on any observation. I told you this earlier. Even with respect to the rotation of the earth, it was much more difficult. Okay, and the first experimental evidence comes only in 1672. Okay, rotation of the earth. So that the earth is spinning. The experimental, after Newton's theoretical formulation of gravity and so on, after people started devising pendulum and then measuring things very precisely with some equations. So this experiment was carried out in Paris, and then it was carried out later in this location. The Paris latitude is 49 degrees close to, and this location is 4 degrees. So the same pendulum kept at different places. Okay, so it was showing some difference in the oscillation period, and thereby, so they had some theoretical framework by which they could do this. So this is not an easy thing. So Copernicus, for instance, see, so Copernicus is not modern. So though he proposed, I am trying to bring this for one reason. So in 1992 there was a paper, I'll just come to that in a minute. So this Copernicus is not modern. His universe is not the infinite space of the classical physics. It has limits, as does the universe of Aristotle. So he was just keeping things. He just transformed some object from some one place to other place. It is certainly much larger. So the sun is at the center, and the sun, and then he further says the spheres. See, he also had this notion of spheres. See, planets. This has to do with the Greek thing. The Greeks. This is one another interesting thing between proposing a model. The Greeks had some fixed notion. They said that all these objects have to be necessarily having uniform motion. One condition. The second condition is they have to be rotating in surfaces which have absolute symmetry. What is the only possibility? You have the thing of spheres. Okay? So this is what they were doing. They were putting these two constraints, and within this constraint they had to do various other things. On the other hand, these Indian astronomers did not put any kind of such constraint. Okay? So that is what this man, this is Alexander Poiré, the quotation is from the book. The spheres being just as real as, the spheres being just as real as the crystal spheres of the medieval cosmology. Okay? So he was adopting the spheres revolve because their shape and so on and so forth. So he was not a great observer. This is another thing that I wanted to point out. Okay. So he was, in fact, he says Copernicus is not a Tycho Brahe. Means Tycho Brahe made enormous amount of observations. Okay. And he came up with another model of motion which was postulated by Indians much earlier. That is what I wanted to tell you. In fact, Ptolemy's astronomy is relatively satisfactory, whereas the Copernicus is hardly much better in practice for calculating the positions of the planets. Okay. This heliocentric motion, I would say, in fact, we wrote a paper. So this was after I started studying this, within 1 or 2 years. So we came up with some interesting things in a work called Nilakanta Somyaji around 1500. So where this, in fact, he was asking this question, somebody was asking this question, Sigrocha. You were asking, right? Yeah. So this Nilakantha says, this you should not call this as Sigrocha, you should simply call it as Mercury itself. The revolution period was not of some fictitious object called Sigrocha, it is only Buddha. Okay? That was a brilliant analysis that he has done based on the latitudinal deflection of the Mercury. See, the point is very simple. I told you that the celestial equator and the ecliptic are inclined by 23 degrees. Most of the planets move in a plane which is close to ecliptic. Ecliptic is the path traced by the sun. Okay? Now, you don't have a full moon or a new moon and an eclipse every time.
Yes.
Why?
Because they are off the ecliptic.
So which means the moon's orbit is inclined to the ecliptic. If it so happens that the moon is close to the ecliptic or the node of the moon, okay, and it happens to be a new moon day, then you will have an eclipse. So the point is, moon's orbit is slightly inclined to the ecliptic. It is roughly 4.5 degrees, 5 degrees. It is a varying thing. The same is true for every planet. Mercury's orbit is inclined, Venus orbit is inclined. They are inclined by a small amount. Now what Nilakantha says is, so the latitudinal deflection, see, it is not an easy thing to measure at all, because Mercury and Venus you can't see. They are very close to the sun. So you should define a plane and then you should see that it is moving above and below, and you should see the latitudinal deflection period of Mercury and Venus is only 88 days, and this cannot happen unless that object is moving. So this is a brilliant thing that he did, and then he nicely formulated various other things. In fact, he says, you see, na swabimbasya vikshepaha. Vikshepa means latitudinal deflection. Swabhramanavashadeva bhavitumarhati na punaha anya brahmanavashad. Okay, the deflection can happen only by its own rotation and not by something else. Therefore, so he finally will say, okay, Tayoho Brahmanavrittena. Tayoho means Mercury and Venus. Brahmanavritta means the orbit. Okay? Na bhuhu kabali kriyate. What does it mean? It does not gobble earth. As these objects move around, they don't gobble the earth. Whereas Jupiter, Mars, etc., as they go around the sun, they will also gobble the earth. Kabalikaranam means swallowing within that. Okay, that is the phrase that he uses. So this is a very important discovery that has been made by Nilakantha. So in a sense, you can call it heliocentric, as far as the planetary motions are concerned. Okay, that was a very clear, important discovery historically. So Copernicus did not make any this kind of logical argument, etc. In fact, somebody says Copernicus, ignorant of his own riches, took upon himself for most part to represent Ptolemy and not nature. You understand? He just makes some hypothesis, but then most of the computations, etc., it was done only that way. On the other hand, Nilakantha presents a comprehensive view of Indian planetary theory, highlighting some of the crucial shortcomings of the traditional model and explaining the appropriate revision that has to be carried out. So Nilakantha, in a sense, was the first servant in the history of astronomy to have correctly applied. There is a technical term called equation of center. Okay, it is just to take the eccentricity of the planetary orbit. Okay, so that he has given for the first time. He was able to arrive at correct formulation by an analysis of the latitudinal motion. That's what I was mentioning. There was no speculation whatsoever involved, unlike Copernican revolution. So this is specified in a text called Tantra Sangraha. So when we came up with this,